Hi, ladies and gentlemen. Notes 3.2 are in completing the square. Completing the square is a really important skill that you'll need to have in order to be able to be successful on the rest of this unit. Okay, so we talked about all of these factoring expressions that we had in class, and we also filled in what do you notice. But one other thing that I want you guys to add on to what do you notice is that if you have x plus r squared, essentially all it is x squared plus 2rx plus r squared, okay? And let's just verify that this is really true right here. So x plus r squared just means x plus r times x plus r. So x times x gives me the x squared. This gives me Rx right here. This gives me Rx right here. So you've got two Rx's. And then we have R times R, which is our R squared over here. Okay, that's really important to know in order to be able to complete the square. Okay, so it says steps to put equations in vertex form. But I just want us to write a quick note about what vertex form really is. So vertex form is just going to be f of x equals a times x minus h squared plus k. So this should be a review from last year. So what we're going to do is we're trying to get a perfect square right here. And in order to be able to do that, we need to get to a point where we have a trinomial that can be factored into a perfect square binomial right here. Okay, so step one, if necessary, factor out the leading coefficient from a and b to make a equal to 1. And remember, by a and b, this is what we're talking about in the form that we're looking at right here. So if you notice right here, all the leading coefficients right here are all 1. But in this example here, my leading coefficient is 2. So I'm going to factor out a 2 just from A and B. Even if it's factorable from C, I'm not going to factor that out, okay? So I'm going to rewrite this as f of x is equal to 2, and then when I factor out a 2 from 2x squared, I get x squared. And then when I factor out a 2 from 8x, I get 4x. And I'm not going to factor it out of my c value. So I'm going to leave the plus 6 on the outside of my brackets. Now, I've not changed this equation right here. If I distribute the 2 through, I end up getting the exact same equation, okay? Now, it says complete the square by determining the missing c value. And in order to be able to do that, I have to take b, divide it by 2, and then square it. So if you notice up here, my first b value here was 10, okay? If I divide 10 by 2 and then I square it, I end up getting 5 squared, which is 25. That's the value here that I need in order for me to have a perfect square trinomial right here. And the reason why that is because if you notice right here, I want just to figure out what r is. So if I look at this right here, this is 2r. When I divide it by 2, I now will only have just the r that I'm looking for. And then to get this last value here, it has to be squared. Okay, so let's see if this works for all of these guys. So I'm going to take the b value here, which is negative 12, divide that by 2 and square it. So negative 12 divided by 2 is negative 6. So here I get negative 6 squared, which is 36, which is exactly what I'm looking for here. I would take the b value of 100, divide that by 2 and square it. Well, 100 divided by 2 is 50. 50 squared is 2500. Okay, here my b value is negative 8. So I would take negative 8, divide that by 2 and square it. So I would get negative 4 squared, which is 16, which is this value that I'm looking for right here. The b value here is negative 3. Divide that by 2 and square it. Well, negative 3 is not evenly divisible by 2, so I'm going to leave it as negative 3 over 2. Well, negative 3 squared is positive 9, and 2 squared is 4, and that's how I get this 9 over 4 that I'm looking for here. And then lastly, I've got 1.4 divided by 2, square it. Well, 1.4 divided by 2 is 0.7, and then when I square that, I get 0.49, which is, again, the value I'm looking for here. So I'm going to do the same thing here. I'm going to take the b value after I factored out the leading coefficient. So I'm going to use the 4 and not the 8 because I don't care about this 8 anymore. So I'm going to take 4, divide it by 2, and square it. So I end up getting 2 squared, which is 4. Now it's not always going to turn out to be this value here. It just happens to be this value in this example. Okay? So then what I'm going to do, step 3 says make sure to add the missing c value and subtract it to balance it out. So why would I do that? You're going to see right now. So what I'm going to do is I'm going to copy down what I have here, 2 bracket x squared plus 4x, but I'm going to leave some space. And then I'm going to write the plus 6 on the end. So we figured out that the value that I need to add on is 4, and that's going to complete the square. So I'm going to write plus 4 right here. But if I add 4, then I also have to subtract 4 because I'm not allowed to just randomly add a number to a function. So I'm going to balance it out by adding 4 and then subtracting 4 to cancel it out. Okay? Now, how is that going to help me out? Now, if you look right here, this x squared plus 4x plus 4 is a perfect square trinomial. So step 4 says keep only the perfect square trinomial in the brackets. So I'm going to say f of x is equal to 2, and then in my brackets, I'm only going to have this x squared plus 4x plus 4 inside my brackets, which means that I want to get rid of this minus 4 from inside of my brackets. Well, I'm distributing the 2 through right here. So I'm going to redistribute the 2 through just to the negative 4 because I want this guy out. So 2 times negative 4 is negative 8, and then I'm just going to copy down the plus 6. Now that I've done that, step 5 says to factor the perfect square trinomial. So what's in purple right here is my perfect square trinomial. So x squared plus 4x plus 4, when I factor that, I'll end up getting x plus 2 times x plus 2, or I can just say it's x plus 2 squared. So that means that I've got f of x is equal to 2, and then this right here ends up being x plus 2 squared. And let's verify to make sure that this is really true. So x times x is x squared. This gives me 2x. This also gives me 2x. So when I put them together, I get the 4x that I want. And then 2 times 2 is this 4 right here. Then I'm just going to put this negative 8 and the 6 together, simplify the constant outside the bracket. So I'm not going to leave it as negative 8 plus 6. I'm going to add them together and I get negative 2. Now it's just a coincidence, by the way, that there's a bunch of 2's here. It doesn't always end up happening that way. And now if you look right here, it is in vertex form because again, vertex form is f of x is equal to a times x minus h squared plus k. I have my leading coefficient on the outside. I've got x minus h right here, it's squared, and then I've got a plus k on the end. It just happens that the signs are different, but it's okay. It just means that the h value here is negative and the k value here is also negative. Now, one thing I want you guys to notice is this value that we have here, this 2, it came from the value of b over 2 right here before you squared it to find the c value, because again, it's just this r value right here. So remember, we take this coefficient, divide it by 2, and that gives me this r value right here. So notice here, when we divided 10 by 2, we got 5. That's what we have right here. When we divided negative 12 by 2, we got negative 6. That's what we have over here. 100 divided by 2 is 50. Negative 8 divided by 2 is negative 4. Negative 3 divided by 2 is negative 3 over 2. And then 1.4 divided by 2 is this 0.7 that we have here. So that's going to really help us out when we get to the point where we want to factor this quickly. So it says to put the following equations in vertex form. So let's just have a quick reminder of what vertex form is one last time. So it's a times x minus h squared plus k. And remember, the parent function of any quadratic is always going to be x squared. And normally here, this a value is still the same. This x minus h, you guys are used to seeing it as x minus d squared, and then instead of plus k, you guys are used to seeing it as plus c. So it's the same idea, and that's why it's in vertex form, because the vertex of your original parent function is 0, 0, but here this is moving h units horizontally and k units vertically, just like this is moving d units horizontally and c units vertically. So your vertex of 0, 0 is changing places. That our vertex went from 0, 0 to hk. So our vertex in vertex form is always going to be hk. And then A tells us how wide or how narrow our parabola is, and it also tells us if it's reflected over the x-axis, which will tell us if it's a minimum or a maximum. Okay, so let's go ahead and do this. So our first step, we said, is to factor out the A value so that the leading coefficient is 1. But since our leading coefficient here is 1, I don't have to do that step. Okay, so then the next step is to complete the square. And in order to be able to do that, I take my B value, which is 9, divide it by 2, and then square it. Okay, so 9 divided by 2 doesn't work out evenly, so I'm just going to leave it as 9 over 2. And then when I square it, I get 81 over 4. So that means that I end up getting f of x is equal to x squared plus 9x, and then I'm going to add 81 over 4, but I'm also going to subtract 81 over 4 so that these two will cancel out and give me 0. So I haven't changed my equation at all. And then I'm going to copy down the plus 14 at the end. Okay? Now, I know that this x squared plus 9x plus 81 over 4 is a perfect square trinomial. So it ends up being f of x is equal to x plus, now remember we said it's the value before you square it, it's the b divided by 2. So it's x over 9 over 2, x plus 9 over 2, excuse me, squared. And then I'm going to copy down the minus 81 over 4 plus 14. Let me just make sure that this really works. So if I were to do, over here, I'll just do it on the bottom right here. X plus 9 over 2 squared means x plus 9 over 2 times x plus 9 over 2. So x times x gives me the x squared that I want. 9 over 2 times 9 over 2 gives me the 81 over 4 that I want. The inner brackets give me 9 over 2x. The outer brackets give me 9 over 2x, so I end up getting 18 over 2, which is 9. So it does work how I want it to work for me. Last thing I'm going to do is I'm going to get a common denominator right here. So I'm going to make this 14 have a denominator of 4. So I end up getting f of x is equal to x plus 9 over 2 squared, and then minus 81 over 4. Plus, now in order to get a common denominator of 4, I'm going to multiply this by 4. Numerator and denominator both get multiplied by 4, so I end up getting 56 over 4. So lastly, when I put everything together, I end up getting f of x is equal to x plus 9 over 2 minus, and then when I put all of this stuff together, I get 25 over 4, which means that my vertex is going to be, originally it was at 0, 0, but this is saying, sorry, this should be squared. This is saying that it went to the left by 9 over 2 and then it went down by 25 over 4. So my new vertex is negative 9 over 2, negative 25 over 4. And because the A value is positive, it opens up still. It's not reflected, so it's still going to be a minimum. Let's do the same thing with the next one. So I want to, first of all, make sure that my A value is equal to 1, so I need to factor out a negative 4. Remember, it's only factored out of the first two terms, out of the ax squared and the bx terms. So when I factor out a negative 4, I end up getting x squared minus 10x, and then I've got minus 9. And notice I'm leaving some space, right? So to complete the square, the next step is I need to complete the square. I take the b value, divide it by 2, and then square it. So I end up getting negative 5 squared, which is 25. So what I'm going to do now is I'm going to copy down the negative 4 times x squared minus 10x, but this time I'm going to add 25. But if I add 25, I also need to subtract 25 to make up for it, okay? So then, next thing I need to do is keep just the perfect square trinomial inside of my brackets. So it's just the first three terms, and then I'm going to distribute the -4 to the -25, and I get positive 100 minus 9 on the outside right here. Okay, so next thing I'm going to do is I'm going to factor my perfect square trinomial. So I copy down the -4, and I know this is going to be x minus 5 squared because -5 when I double it is -10, and -5 when I square it is positive 25, and I also got -5 before I squared it out here. And then when I put these guys together, I end up getting 91. Therefore, this is my answer in vertex form, just like this right here was my answer in vertex form over here. Therefore, my vertex is going to be 591, but the leading coefficient is -4. The a value is -4, which means that my graph is narrower, and it's reflected in the x-axis. So this is going to be a maximum. And that's my answer for the middle question. All right, last one has a lot of fractions, so pay extra close attention to this last one right here. So first thing I'm going to do is I'm going to factor out that 3 from the ax squared and the bx part. So when I factor out the 3 from 3x squared, I get x squared. When I factor it out from -7, I get -7/3, because 3 times -7/3 is going to be -7. Then I've got +2 on the outside. Now, when I complete the square, what I need to do is I need to take my b value, which is -7/3, and then I have to divide it by 2 and square it. Well, I've got fractions within fractions, and I don't want to have to deal with that. So what I'm going to do instead is I'm going to take -7/3, and instead of dividing by 2, I'm going to multiply by the reciprocal of 2, which is 1/2, but I still have to square it. So then I end up getting -7 times 1 is -7, 3 times 2 is 6. So I get -7 over 6 squared, which is 49 over 36. So now what I'm going to do is I'm going to add that 49 over 36, but I also need to subtract it to balance it out. So minus 49 over 36. And then I also have this +2 on the outside. So all I did was I copied everything down here, and then I added 49 over 36 and subtracted it here to complete the square, here to balance it out. So now I'm only going to keep my perfect square trinomial inside of my brackets. So only the first 3 terms, and I'm going to distribute the 3 to the -49 over 36. Well, I'm going to do that on the side right here because there's a lot of stuff going on over here. So I'm going to take 3, multiply it by -49 over 36. So this is 3 over 1, and I see that the 3 and the 36 both have a 3 in common, so the 3 becomes a 1, the 36 becomes a 12, so I end up getting -49 over 12. So on the outside here, I now have minus 49 over 12, and then I'm just going to copy down the +2. Okay, so next I'm going to, and I probably shouldn't have deleted that. So next what I'm going to do is I'm going to factor what I have inside here. So I've got 3, and then this is going to be x minus, and I look right here, and the number I got before I squared it was 7 over 6. And I know that that works because when I double 7 over 6, I get 7 over 3. And when I squared -7 over 6, I get 49 over 36. And then here, I've got minus 49 over 12 plus, and then to get a common denominator here, I am going to make this over 1 and see that I need 12 as my common denominator. So I'm going to multiply by 12 over 12. So I end up getting 24 over 12 right here, which means that I end up getting f of x equals 3 times x minus 7 over 6 squared. And then when I put these guys together, I get minus 25 over 12. Which means that my vertex, so this is in vertex form, and then my vertex is going to be positive 7 over 6, negative 25 over 12, and it's going to be a minimum because the A value is positive, which means that it opens up. Remember, the A value here is negative, which means that it opens down. Now, one last thing. In this example here, if you wanted to use decimals, that's okay because this is a terminating decimal. But when you have a repeating decimal, you need to keep it in fractions so you have the most accurate final answer. Okay?